All right, so we're going to be looking at transformations of 1 over x. So this is sometimes called a rational function. It is a form of rational function, of course, with the x being on the bottom in the denominator, but sometimes also just called the reciprocal function. And we'll talk a little bit more about that as we get going. I think there's a typo on your sheet. It says square root x here. We'll call the key points of f of x equals root x, but should be 1 over x. So I corrected it on mine. Hopefully you can scratch it out, correct it on yours. But let's look at the key points. Okay, so f of x. Okay, so the key points are a little bit different for this one. I guess they're a little different for all of them. But we're going to do -2, -1, and -1/2. We'll pause there. There are more, but let's just do these ones for now. Okay, so if we plug this in, we're going to get 1 over -2 is -1/2. And this is one of the reasons it's called the reciprocal function, because these are reciprocals. They're flips of each other, right? Flipping a fraction is called a reciprocal. So -1, we plug it in, we just get -1 back. -1/2, the reciprocal of that's -2. If we plugged it in and we'd have a 3-layer fraction, it'd be a little weird, but we could work it out and we get -2. So it's -2. Now, the next point you might want to try is 0, but what would happen if we put 0 in here? Well, we'd be dividing by 0, and as we talked about in our rationals unit, that's illegal. Can't divide by 0. So we're going to skip over that one. We're going to go to +1/2. Okay, so we plug in 1/2, we get reciprocal is 2, plug in 1, reciprocal of 1, plug in 2, reciprocal of 1/2. So we kind of get these like two sets of very symmetrical points, right? 1/2 and 2, 2 and 1/2, 1 and 1. Okay, and the negative version as well. Now when we graph these, it's not necessarily apparent exactly what our graph will look like. So let's do that for a second. So we do -2, -1/2, -1, -1, -1/2, -2. And then we go to our positives. We get 1/2, 2, 1, 1, 2, 1/2. And from here, it's not obvious what our graph is going to look like. Now remember what we said earlier, that this graph can't exist with x is 0. If I plug in x at 0, I get a restriction. It's an illegal thing. So what happens is we get what's called asymptotes. So we actually have a vertical asymptote, which we're going to represent as a dashed line. We'll talk about what an asymptote is in a minute. Okay, so we have this vertical asymptote here, and that's because that's a restriction. So all that work we did with restrictions, if you do advanced functions, you learn far more about it. And if you take calculus vectors, you learn even more about how these restrictions appear on graphs. Okay. Now there's another asymptote, and it's not because of a restriction, but it is the y-axis. So we're going to draw another dashed line going along the y-axis. Okay. Now these asymptotes, so let's just write a little note to ourselves here. Note the x-axis and y-axis are asymptotes. Asymptotes. Probably the best word in grade 11 math. All right, so they are asymptotes. So, of course, you should probably define what an asymptote is. Okay. So this is a bit of a simplification of the definition, but it's more than enough for what we need for grade 11. So an asymptotes are lines the graph approaches. Okay, so an asymptote is a line our graph approaches. Now, some people will say an asymptote is a line the graph approaches but doesn't cross. That's usually true, and in grade 11 that's always going to be true, but I'm not going to write it down because it's technically not always true. But that's a good way to think of it. So our graph here is going to approach this. So if we look to the left here, it's going to approach the y-axis, go through both these points, and then approach the x-axis. Okay, so it's getting closer and closer, and if we kept going and going and going and going, the graph will get closer and closer and closer and closer and closer to the x-axis. That's what we mean by approaching. And the same for this section down here. It approaches the x-axis towards the left, approaches the y-axis towards the right. So we try to represent that well with our curve. It can be a little challenging. All right, so that is our graph of the reciprocal function 1 over x. Okay, now of course we're going to do some transformations. Transformations, once again, work basically the same. A little few interesting things happen with these asymptotes when we do some of them though, so we'll see that. So let's do our first one here. So the first one we have to do is we have a vertical stretch by 2. Vertical stretch by 2. And remember, algebraically, that's going to just be our y's times 2. So inside the function, we have x minus 1. So that's going to be right 1. And outside here, we have plus 1. That's going to be up 1. Now, because our graph's in 2 pieces, we're going to, for the most part, avoid drawing our parent function every time. Otherwise, our graphs are going to get extremely cluttered, especially with the asymptotes in and stuff like that. It gets way too cluttered. So we're going to restrict a little bit how many we draw. But we're still going to write out the table of values for it. So let's do x, f of x. So write out our table of values. -2, -1, -1/2, 1/2, 1, 2. This one I think is the hardest one to memorize and to remember the all the points, or all the x's, all the x values. And the reciprocals for the y's. So -1/2. -1 is its own reciprocal. -2, 2, 1/2. Okay, so we're going to skip graphing these just because our graph is going to be way too cluttered if we do it. But let's do that transformation we have written up here, multiplying our y values by 2. So these right values. So the x values stay the same. So I'm going to copy those down first. -2, -1/2. Oh, I missed one. I missed my 1. Can't do that. -1, -2, -1, -1/2, 1/2, 1, 2. Okay, so now we want to be multiplying our y's by 2. So -1/2 times 2 is -1. -1 times 2 is -2. -2 times 2 is -4. 2 times 2 is 4. 1 times 2 is 2. And 1/2 times 2 is 1. And we'll start off by graphing this. So this would be 2f of x. Okay, so let's graph this one here. So -2, -1. We got a dot. -1, -2. -1/2, -4. Okay. And then we have 1/2, 4. 1, 2. And 2, 1, I believe. Let me double check those. Looks good. Okay, so our curve doesn't look as symmetrical anymore, but the curve should still be symmetrical. And if we draw in our asymptotes again, just draw those dashed lines. You can draw them in lightly, or you can just remember they're there if you're writing with pencil. It can be a little more difficult to draw them or to see them. It's easier with me with a colored marker. So our asymptotes are still there, so we're still approaching those. So we can see we swing through all our points, and then we're still approaching. And we said we had a vertical stretch, and we don't have the graph on here, but I'm going to scroll up real quick. So see, this one comes in a little tighter to our origin and to the axes, and this one takes longer to do that. And that's part of what the stretch looks like on a reciprocal function. Let's go through these points. And there we go. Okay. So the last thing we need to do is our translations. Now, when we do these translations, a really important thing to note, we're going to write it down here maybe at the bottom of your page. So note, when we move our points, we also are going to move the asymptotes. The asymptotes also move. So when we move our points, the asymptotes move too. All right, so let's move our asymptotes first. So we got to move right one. Now, the horizontal asymptote here, if you move it right or left, nothing happens. It's an infinite line. It goes forever. But the vertical one definitely moves. So move this one right one. So now it is on x equals 1. And we'll move our other one up 1. As best we can. Using a ruler can make this a little neater if you would like. Okay, so now we got to move all our points. So we're going right 1, up 1. So we'll take this point, go right 1, up 1, and new dot. I'm going to draw them nice and big so they're easy to find. Right 1, up 1. And this one, right, it's on a half, remember? So right 1 in the middle, up 1. Okay, and let's concentrate on this section first. So we're still approaching the asymptotes, but we have new asymptotes. So now it's approaching these asymptotes. Okay. And do the same with these points. Right 1, up 1. We're kind of off the graph a little bit, but I think we can get that one in. The points right here, right 1, up 1. Right 1, up 1. Okay, and once again, we can extend our asymptote off the graph a little bit. And we get our graph. So we should label them real quick. So this blue one, we have 2 pieces of it, so it's worth labeling it twice. So this is 2f of x, and so is this one, 2f of x. And our green one is our g of x. So we'll once again label that twice, g of x. Some students, especially when we're doing these ones and there's a lot of stuff going on, when they're confident in their answer, they like to use a highlighter sometimes. When we do, say, a test or an assignment and you have to do these graphs, I'm going to give you a bunch of blank extra graphs because some students will like highlight it and they'll look at it later and like, oh no, I made a mistake, but it's permanent. And then you can just like say, refer to one of the blank graphs. So don't be afraid to try to color code yours as well. I'll get you some blank graphs if you need them. Okay, let's try another one. So this one is in the rational form, so it's not in that function notation form. And it's a little bit different to pick out what is inside or outside of a function here. So the general rule of thumb is that the things on the bottom of the fraction are the things that are inside the function. So what's inside our function here? Just this x plus 2, so that'd be a left 2. So maybe let's write that one down real quick. Left 2. And the thing above the function is a multiplication. Another way to think of this is it's negative 2 times 1 over x plus 2. It's just kind of been combined for us. So this is a vertical stretch by 2. And it's negative, so it's a vertical reflection. And both of these together mean we want to multiply our y's by -2. Okay, and lastly, we have this. It's after the fraction, so it's outside of the function, and it means down 0.5. All right, so let's start this process of graphing. So we're going to go make our tables of values. -2, -1, -1/2, 1 over 2, 1, 2, and the reciprocals. If you find it hard to keep track, you can draw some horizontal lines to break everything up. Especially when you're writing fractions, it can get a little challenging. Okay, and we're going to transform this. And we're going to have to multiply the y's by -2. So once again, the x's don't change. So we'll write those in again. And we're going to multiply these by -2. So calculator's your friend here, but you can maybe do them in your head as well. So -1/2 times -2 is 1. -1 times -2. Oh, I just realized something. I missed a negative sign over here. That was about to screw me up. I'm glad I caught that. Okay, -1 times -2 is +2, and -2 times -2 is +4. 2 times -2, -4. 1 times -2, -2. Half times -2 is -1. All right, so let's graph these points in. Okay, so -2, 1, -2, +1. So we get a point here. -1, +2. -1/2, +4. So notice we're in a different quadrant this time. It's interesting. It's probably because we had a reflection. Kind of makes sense. If we have vertical reflection, the points that were in this quadrant here should reflect up to this top quadrant. That kind of makes sense. Okay, 1/2, -4. 1, -2. -2. Sorry, 2, -1. I'm not going to draw my dashed lines in for the asymptotes this time, just to make the graph a little cleaner. But we can draw in our sketch. We're approaching those asymptotes. But make sure we don't touch them. Can't touch them. Okay, so next thing we want to do is we want to move left 2 down 0.5. So let's draw in our new asymptotes first. So left 2, so we're going to have a vertical asymptote at -2. And down 0.5. That's a little trickier one. That's kind of in between here. Okay, now let's move our points. So left 2, 1, 2, down 1/2. Left 2, 1, 2, down 1/2. Left 2, 1, 2, down 1/2. Okay, I'm going to extend this asymptote so I can draw approaching it a little better. Ooh, that's not very good. Try drawing the curve for these 3 points first. Okay. And left 2 down a half. So 1, 2 down a half. 1, 2 down a half. 1, 2 down a half. Right around there. And of course we should label these graphs. So the blue one here is, oh, we didn't label it here either. That was going to be negative 2 over x. So negative 2 over x. And up top here we'll label it negative 2 over x. And lastly, our green graph is g of x. G of x. G of x. Okay, so there's our graph. Okay, so for our last one here, we're actually going to modify the question a little bit. So this was perfectly graphable. It just because all the points get really, really tight together and it's a little hard to see what's going on. So we're going to change it. We're going to change this 5 into a 2. And that's just going to make our graph a little more readable. Okay, so let's identify all our transformations first. So we have a number on the top. Remember, the number on the top is our vertical. So this is a vertical stretch by 3. So that'd be the same as y, our y's times 3. We have this 2 on the bottom multiplying the x. So that's inside the function because it's on the bottom. So this is going to be horizontal. And it's going to be a compression by a half because we have to flip it. Compression by 1 over 2. So that means this x times a half. Okay, and lastly, we have down 1. Okay, so let's do that. Let's multiply or do our starting table of values. X 1 over x. I'm going to do it a bit quicker this time. Okay. And for our transformations, so we're doing 2 things. Let's start with the x's. Multiply them by a half. Multiply them by a half, so we'll get negative 1, negative a half. Maybe I'll write some decimals in. I think that's just going to be a little easier to stay organized that way. So that'd be negative 0.5 and negative a quarter, negative 0.25. Then half of a half is a quarter, 0.25, 0.5, and 1. Okay. Now we need to multiply our y's by 3. So then we're going to get like negative 1.5, negative 3, negative 6, 6, 3, 1.5. Okay, so let's start by graphing this. I think we got some values here that might be a bit off our graph, but I think we can squeeze them in anyways. So we got some 6's here. All right, let's start with negative 1, negative a half. Sorry, negative 1, negative 1 and a half. Negative 0.5, negative 3, negative a quarter, negative 6. So that one's going to be way down here. I think I can get that in. Maybe it's even a bit lower. Somewhere around there. If you're uncomfortable getting that in accurately, you can leave that point. But okay. And I'm just going to draw that sketch while I'm scrolled down. So our asymptotes are still the same. We haven't done any translations. Okay. And then 0.256. About up there. 0.5, 1. What is that value? 1.5. All right, so we draw our curve in with our, keeping our asymptotes in mind, which should be approaching those values. Okay, so now we just need to do down 1. So let's move our asymptote first. Well, let's label these real quick. So this is 3 over 2x. So that's 3 over 2x. Okay, so use our asymptote, move it down 1. Take all our points, move them down 1. So this is going to go down to 5, down to 2, down to 0.5. Okay, and where are we here? 1, go down 1, down 1. I mean, I can guess where this point's somewhere around here, but that one's getting pretty hard to graph now. We've guessed twice. So if you would want to leave it off, that would be fine. We're coming from our asymptote through our points, and then approaching our second asymptote. All right, and lastly, we just need to label these as g of x. So this is g of x, and this is g of x. All right, that's it.